Okay, in this video I'd like to walk through a little bit of the mathxl number 10 that was assigned this week. I've been getting a couple questions about how to interpret these problems and what to do to complete them. And so the first thing that I'll try to remind you of is that anytime that we're being asked to evaluate an inverse trigonometric function, we have to keep in mind that we're supplying either a side length ratio, or if you want to think of it as a position inside the unit circle, we're providing an xy coordinate to the argument as opposed to an angle measure. So if I see a problem like this that says sine inverse of negative 1/2, let me double check that here. Yeah, negative 1/2. I'm asking myself, where in the unit circle does the sine equation or sine expression come out equal to negative 1/2? And so to my mind, a y value is associated with the sine function, so that's in these two positions. And the two angle measures that make that happen are 210 degrees and then also 330 degrees. And if we were thinking about radians, we might say something like this. Well, this is 1 pi radians and another 1/6 of a pi beyond that, so I could call that 7 pi over 6 radians, or this is 1/6 of a pi radian short of a full circle, so I might call this one 11 pi over 6 radians. Now these are the answers that I would expect to see if I were giving this question to you on a test or a quiz. However, mathxl may be asking for something slightly different. Now I don't see anything really clear in the instructions. It simply says to select the right choice and fill in the answer boxes. And if I choose A, which I think I will because there is a solution to this, it says type an exact answer using pi as needed. So that tells me that they are considering our answer in radians. And then it also says to use integers or fractions for any numbers in the expression. So for me, I would answer like this. However, I'm also a little bit hesitant because I think mathxl might be requesting answers that you might see coming off of a calculator. And coming off of a calculator, or if we think about a restricted domain for the sine function, all solutions for sine exist in the right hemisphere of a unit circle. Now that's going to take a little bit of explaining to do in person, but if you recognize that a sine function's results should come from the right semicircle, then what I'm going to do is I'm going to report this answer. So let's see what happens if we supply 11 pi over 6. Okay, so I have it entered in here. Let's see what happens if we press enter on our keyboard. And it did not like that answer. So if we're looking at this for a context clue, here they're reminding us that the y value does exist from negative pi over 2 to positive pi over 2. So that's our reminder that we're talking about an angle measure in the right half of our unit circle. But you'll also notice too that this is a value measuring an angle measure from 0 to negative pi over 2 in that lower quadrant. So this 11 pi over 6 doesn't fit there, even though I think it's correct. In its place, what I might write is negative 1 pi over 6, because a negative 1 pi over 6 lies in the same position as 11 pi over 6. Here again is where knowing your unit circle comes in really, really handy. So that position was correct. The answer that they're expecting to see is negative pi over 6 instead of 11 pi over 6, even though those two components are in the exact same position. For cosine, on the other hand, the solutions will exist in the top half of a unit circle. So if I look for cosine inverse of negative 1/2, that would look something like this. Cosine inverse of negative 1/2. I'm thinking about the unit circle where the x value is negative 1/2. Well, that's here and here. Now, again, cosine requires a solution to exist in the top half of the unit circle based on its domain restriction. Again, we're going to have that conversation in person at another time. But if the solution exists up here, then the angle measure that produces that position, I would say, is 120 degrees. And 120 degrees is also known as 2 pi divided by 3 radians. And so based on the prior result, I suspect 2 pi over 3 is the answer that they would like to see. So let's type 2 pi over 3 go. So that's the process that I would go through for these questions. For tangent, we want a y-coordinate divided by an x-coordinate that ends up equaling this ratio. So where does tangent end up equaling 3 root 3, or I'm sorry, it was negative root 3 over 3, I believe. And it's worth noting here that the square root of 3 divided by 3 is actually the result of a complex rational expression that would have been simplified from 1 over radical 3, and the xy coordinates that make that happen are 1 over 2 and radical 3 over 2. So if we've got a y-coordinate that's 1/2 and an x-coordinate that's radical 3 over 2, that's going to ultimately simplify to radical 3 over 3, but we also have to account for this negative sign. And to do that, we can say either the y-coordinate was negative, now that expression reduces to negative radical 3 over 3, or we could say that the x-coordinate was negative, and this expression also reduces to radical 3 over 3. Well, here again, knowing where the domain restrictions for tangent exist, and that happens to be in the same location that sine is restricted, we only want angle measures that exist here. So a y value of 1/2 with an x value of negative radical 3 over 2 would have been in this orientation, which is not within our domain restriction, but a y value of negative 1/2 with a positive square root 3 over 2 for the x-coordinate would be in this position. And so that's the angle that we're after. This is 30 degrees below horizontal, or pi over 6 below horizontal. So for this question, I would answer with negative pi over 6 as well. So let's go ahead and try that one. Negative pi divided by 6. And that looks like a good solution to me. And for the last problem that I'll discuss in this video, let's take a look at something like this. Now, we are going to see composite functions, but it's important to note that one trigonometric function is undone, or is solved, if you will, by its inverse. And so even though I don't know what the y divided by x component is going to be when the angle measure is 8 pi over 9, I do recognize that that position, when acting as an input to the inverse function on the outside, will simply undo one another. Now, since tangent inverse and tangent are inverses of one another, or opposites of one another, they essentially cancel. And normally our result would simply be the value that's left behind. So let's go ahead and try that. 8 pi over 9. And this is kind of interesting because 8 pi over 9 is not even a value that we commonly recognize inside the unit circle. Now, here's where, again, I tend to have trouble with mathxl, or disagree with mathxl, because while we're talking about the inverses here and they should undo one another, it's not quite that easy because we have to consider our domain restriction. And we're again being reminded here that our value for x has to exist somewhere between negative pi over 2 and positive pi over 2. So if we consider this diagram, it might help. 8 pi over 9 is just a little bit shy of 1 pi radian. So the position for that angle is right around here. It's pretty close to perfectly horizontal on the opposite side of the unit circle. Now, if I were able to identify the x and the y coordinate at this position, I could divide those two and find the result for tangent at 8 pi over 9. And then I can use that number inside of tangent inverse computation. But what I'd like to remind you of is that the tangent function likes to live here in this domain on the positive right side of our unit circle. So if you think about the angle measure that sits here at 8 pi over 9, its calculated result is actually the same as this position here, which is negative 1 pi over 9. And if I were to evaluate tangent inverse at negative pi over 9, I should say tangent inverse of tangent evaluated at negative pi over 9, I'll obtain the exact same answer because of the relative x and y values in this quadrant. This positive x this positive x value divided by the negative y value is exactly the same as this positive y value that's being divided by this negative x. And actually I said that backwards. We need to be thinking y divided by x for tangent. So negative x positive y is the same as negative y divided by positive x. And I'm getting myself confused and mixed up there because of the required domain restrictions. So in any event, I think the proper answer here should be negative pi over 9, because when we consider our domain restriction for the tangent function initially, we do end up with the desired result. So let's go ahead and pull up our keyboard. And there we go. mathxl does prefer that as a result. So I understand that this is can be quite confusing, but if you consider watching the videos that I've posted online and listen to others as they talk about domain restrictions, that should help. And if you need any specific questions answered along the way, feel free to reach out to me and I'll try to address those this week and next. Thanks for watching.